So the video for homework 5 is asking to look at the improper integration ln of x squared dx from 0 to 1. And decide if this is convergent or divergent and prove that it's that way, and whatever the guess is, and then if it's convergent, calculate it. So, I mean, if we put this into Mathematica, we get the integral is 2, which sort of means that we should prove that this is convergent. So, why is it improper? Well, if you look at the graph of ln of x is going to be from 0 to 1, it's just going to be going to negative infinity, and then after that it goes to 0, and then it grows really slowly to infinity. And if you square that, right, you get something like, let's say, suppose you go from 0 to 1. Of course, this is going to go up because it becomes plus infinity, and it goes down to 0. But since the values here, we're going to get close to 0 when you square it, it's going to be a lot closer to 0. So maybe we can plot this. Let's see if I copy this and plot it. Instead of computing the integral, notice we have the graph kind of like this, and so the area, all this region, it's actually finite, and it's equal to 2. Okay, so that's what we need to show, that is convergent and is 2. Now, get rid of this thing so we're not going to be in the way. Something is wrong with this. Doesn't want to be controlled. Output. Okay. So what we're gonna do is, this is by definition, this is improper. Because it's unbounded. So function which is unbounded, usually we don't consider that to be Riemann integrable. Remember, one of the terms we had that Riemann integral means it's bounded. So in other words, this, by definition, is the limit when, let's say, epsilon is 1 and epsilon goes to 0, it's ln of x squared dx. So what we need to do is compute this antiderivative, and evaluate it from 0 to epsilon to 1, and then let epsilon go to 0. So if I take epsilon here, this is gonna make sense because the function over there is continuous from epsilon to 1, it's continuous. And then you pass through the limit and show that the limit exists and it's actually 2. So showing that's convergent is showing that this limit exists and is 2. So in order to compute it, the best approach would be to make a change of variable, right? So ln of x equals t. So this would be equal to the limit of t squared And then if you differentiate this, you get 1 over x equals dt, right? dx over x equals dt. So dx is x dt. But x is e to the, take the inverse of ln, put it to the other side, would be e to the t. So this is e to the t dt. Now what are the limits? Well, the limits change, right? So 1, the limit of 1 is 0. So this is going to go from something to 0. When you plug in epsilon in there, you get t to be ln of epsilon. So ln of epsilon is close to negative infinity. So this is basically like something close to negative infinity all the way to 0. Right, when epsilon goes to 0, ln goes to negative infinity. So we can change this to a different limit now and call this epsilon, let's say s. The limit as s goes to negative infinity, here epsilon still goes to 0, but then s will go to negative infinity. And now we know how to integrate that. We use the formula, which is integration of a polynomial of, let's say, u e to the u du is e to the u times p minus p prime, and so on. So we subtract, add the derivatives. When we do the derivative of that, we get exactly this. Because the derivative of e to the u is the same, and then you get all these terms, and then when you do the derivative of that, you're going to get exactly these terms, which will cancel out. So let's apply the formula. So this is going to be t e to the t squared minus 2t plus 2. Right? This is the polynomial time minus the derivative plus the second derivative, and then after that will be 0. So this is going to be from negative infinity to, negative from s. Because now we have s on the bottom to 0. So this is going to be the limit of, when you evaluate this at 0, you get 2. So this is limit of 2 minus. Now evaluate this at s. So this is going to be s squared minus 2s plus 2 e to the s. S going to negative. Okay, so now let's change, let's see what happens. We can change again the variable. Instead of going to negative infinity, I'm going to go to plus infinity. So let's say z. Z is equal to negative s. So change the sign. So this is going to go to plus infinity. The reason I do that, because this is going to become a limit in the form of a function of another function, and then we can apply l'Hopital. Now this constant goes in front. So this is going to be 2 minus limit of z going to infinity Now, e to the s. S is negative z. So we know that e to the negative z will be 1 over e to the z. Negative s, s squared would be z squared. And then negative 2s would be 2z. And then plus 2. Now, when we look at this limit, this is a function of another function. And on top, you have a polynomial. On the bottom, you have an exponential. The polynomial goes to infinity. Of course, infinity squared plus 2 times infinity plus 2. So this is infinity over infinity. We can use log. This is going to be 2 minus limit. Derivative of that would be 2z over e to the z. That simplifies it a little bit. Or we can use L'Hopital again. And then so that's going to be 2 minus limit of 2 over e to the z. Now we don't really have infinity over infinity anymore because it's 2 on the top and infinity on the bottom, so that's going to be 0. But if we do we still can apply L'Hopital because one of the things in Calc 1 is that the case of L'Hopital when you have infinity on the bottom doesn't matter what's on the top. So as long as you have infinity on the bottom, you can still apply L'Hopital. So if we apply L'Hopital again, of course this differentiates into 0 and you get 2. So then that's the answer. And this shows that, going back, this shows that this limit exists. That means this integral, this improper integral is convergent, and its value, right, is 2. Which in terms of geometry, it means that this area under the graph adds up to 2. Well, of course, we cannot really go all the way to infinity, but what it really means that if we draw a line here, whatever it's underneath is going to be something less than 2, but it's going to be pretty close to 2 if we put the line pretty close to 0. So that's the whole thing, and that's the image. You already did it, right? You already submitted. Is that what you did?
Yep.
Did you apply? Did you use the formula?
Mm-hmm. Yeah.
Oh, good.
I don't think I wrote it down specifically on mine, but yeah.
You used the formula.
Yeah.
Okay. Good. Well, that's gonna be the last video. I don't think that. Oh no, there is another video for number 6. So we'll do that on next Thursday. Well, what day is that? Today is 26, right?
Yeah, 26.
26. So then we're gonna have. What's happening here? I don't even have a calendar anymore. So the next Thursday is the 3rd. So
Yeah.
before the 4th of July. Are you going anywhere?
No, staying there.
Staying here.
Yeah.
So we meet then, and then a week from then, it's gonna be the end of the summer classes, and we're probably gonna wrap it up soon after that. Because I think the grades are due somewhere about 15 something. I forgot what the grades are due.
No, I think a little later.
So
I think
we're gonna-
final exam days are 17th.
Right, but I'm gonna open the
Yeah.
I'm gonna open the final on the 10th.
Yeah, I think the grades are due like probably the 20th.
That's when the grades are due?
Yeah, because the set final exam days are 17, depending on the class. Yeah,
Right.
17, 18, 19.
Right. Well, but I wanna finish this before.
Yeah.
before that. You asked me about the end of this, right? Or somebody else asked me about the end of it?
I don't think I did.
No? Okay, we'll stop here. Close this.